Introduction. Choosing the appropriate tools, method, and material is crucial to producing accurate and trustworthy results in scientific research. Reagents are the chemicals used in the reactions of processes. Techniques are the methods used to accomplish the study's objective. And apparatus are the instruments and equipment used in experiments. The study's tools, methods, and chemicals are covered in this section. Each was picked with care to guarantee precision, dependability, and security. Objective for this presentation is number 1, general objective of using apparatus, techniques, and reagent in scientific work. 2, specific objective of a particular experiment or field. 3, educational objective for teaching how to use them. And 4, safety and operational objective. This is 20 common laboratory apparatus names and their uses. Beakers, watch glass, microscope, test tube, spatula, crucible, balance, wash bottle, burette, tongs, ammeter, funnels, volumetric flask, brushes for test tube, thermometer, measuring cylinder, spring balance, magnifying glass, dropper, and Bunsen burner. There is 3 types of analytical balance. 1, mechanical analytical balance. 2, electronic analytical balance. And 3, top pen balance. Next is analytical balance safety procedure. Do not use balance at dangerous places like dusty room, near gases supply, or near flammable fluid or solvent. Make sure that the balance is handled with care. Do not dismantle the analytical balance. Next is analytical balance care and uses. Always handle the analytical balance with great care. Never drop the analytical balance. This is general rules for weighing how to use balance. Number 1, warm up the analytical balance for at least 30 minutes before use. 2, turn on the power. Use clean paper or vessel. 3, place the substance at the center of the pan. 4, ensure objects are at room temperature before weighing to avoid errors from air currents caused by heat. 5, never place chemicals directly on the pan. Use a proper container. 6, use a soft brush to clean up any spills immediately. And lastly, close the balance case door during weighing to prevent air currents from affecting accuracy.
Pipette used to transfer a particular volume of solution. 2 common types. 1 is TD, to deliver, used for accurate measurements, and 2 is TC, to contain, used for accurate measurement, especially for small volumes. Next, we have burette, used for accurate delivery for a variable amount of solution. The volume delivered can be weighed to the nearest 0.01 ml by interpolation. Volumetric flask, used in the diluting of a sample or solution to a certain volume. The flasks are designed to contain an accurate volume at the specific temperature, 20 or 25 Celsius. When of the manuscript just touches the line across the neck of the glass.
Calibration of volumetric glassware. Why we need to calibrate the glassware is to ensure accurate volumetric analysis. Generally, calibrate glassware to 5 significant figures. The maximum precision are likely to attain or delivering solutions. Hence, your net weight of water needs to be 5 figures. If the glassware exceeds 10 ml, this means weighing 1 mg is all that needed. This can be used a top loading balance for convenience instead of a sensitive analytic balance. Next, I will explain the technique to calibrate 15 ml pipette. The first step to calibrate 15 ml pipette is determine the mass of the empty stopper receiver to the nearest milligram. Second step is transfer the 15 ml volume from pipette into a stopper container. Third step is weigh a stopper receiver and its content and calculate the mass of the water delivered by difference. Fourth step is from the delivered mass of water, calculate the volume delivered using the appropriate density data table. The last step is repeat the calibration 3 times and calculate the mean volume delivered and the standard deviations. Now let's move on to calibration technique for a burette. Calibrating a burette is similar to the procedure for a pipette. except the several volume will be delivered. The internal bore of the burette is not perfectly cylindrical and it will be a bit wavy, so the actual volume delivered will vary both plus and minus from the nominal volume mark on the burette as increased volume are delivered. The last calibration technique is for 15 ml and 100 ml volumetric flask. The first step is weigh the flask. Record the mass of the empty, clean flask and its stopper. Second step is fill to the mark. Use a pipette to transfer water into the flask up to the calibration mark and ensure no droplets remain on the neck, blow if necessary. Third step is weigh again. Measure the mass of the filled flask with the stopper. Fourth step is calculate volume. Use the mass of the water and a density table to determine the volume delivered. Last step is repeat and analyze. Perform calibration 3 times to calculate the mean volume and standard deviations.
Furnace function used when heating a substance in a beaker or crucible supported on a wick stand or triangle. To adjust our mixer well, one is flammable hotter and larger. Open the air mixer well continually. Then we have flammable, cooler and smaller. Close the air mixer well. Complete function used for speedy heating up of any solution in a container or under controlled temperature. Ovens function. A drying oven is used to dry samples prior to weighing. The ovens are well ventilated for uniform heating. The usual temperature required is about 110 Celsius, but temperature of 200 until 300 Celsius can obtain. Furnace function to heat sample at high temperature. The temperature can up to about 1200 Celsius, higher than oven. Since use of some metal may occur at temperature in excess of 500 Celsius. Water bath function used to incubate sample in water at a constant temperature, stable, over a long period of time. The temperature from ambient up to 80 Celsius or 99 Celsius. Boiling bath will boil water at 100 Celsius under normal conditions.
Now I would like to explain about desiccator, care and usage. Desiccator is a device for drying substance or sample. It prevents reabsorption of moisture after oven drying and keeps sample dry while they are cooling and before they are weak. As an airtight container that maintains an atmosphere of low humidity. A dry of ignited sample and vessel are cooled in the desiccator. The top of the desiccator should not be removed since the moisture from the air introduced is rather slow and continued exposure will limit the lifetime of the desiccant. This is the component of the desiccator. The first one is desiccator plate. This is a perforated plate placed inside the desiccator to hold the item that we want to keep dry. The second one is desiccant. This is a substance placed at the bottom of the desiccator to absorb moisture from the air, keeping the humidity level low. Examples of desiccants include silica gel, calcium chloride, and calcium sulfate. How the desiccator works is the desiccants absorb moisture from the air inside the desiccator. By trapping the moisture, it creates a dry environment, protecting the material stored above the plate from damage caused by humidity. Why it's important? Because it can prevent degradations of hygroscopic material and ensure accurate experimental result by keeping reagent and sample moisturized free.
Titration apparatus and technique. Titration is laboratory method used to determine the concentration of unknown solution by rating it with a standard solution of no concentration. Titrine in the burette. A solution with no concentration add to the analyte, usually a strong acid or base. Analyte in the flask. The solution with unknown concentration whose concentration is determined by reacting with the titrine. Indicator, a substance that shows the end of the titration. Technique. Preparation. Clean all glasses, rinse with distilled water, then rinse with the solution they hold. Fill the burette with the titrine, making sure there are no air bubbles in the tip. Second, initial reading. Record the initial volume of titrine in the burette. Titration. Add the titrine slowly to analyte while swirling the flask. The end point is reaching when the indicator changes color. 4. Final reading. Record the final volume of the titrine in the burette. 5. Calculation. Subtract the initial reading from the final reading to find the volume of titrine used. Use this volume to calculate the concentration of the unknown solution. Filtration apparatus and technique. Filtration is a common laboratory process used to separate solid from liquids or gas using a filter medium that allows the fluid to pass but not the solid. Type of filtration. Gravity filtration. Use gravity to pull liquid through a filter. Vacuum filtration. Use a vacuum to accelerate the filtration process. Apparatus. Filter paper used to trap solid particles while allowing liquid to pass. Funnel. Hold the filter paper and direct the flow of liquid. Aluminium flask. Beaker. Collect the filter liquid. Filter it. Buncher funnel for vacuum filtration. A flat bottomed funnel that uses the vacuum to draw liquid through the filter paper. Vacuum flask. A flask connected to a vacuum source to accelerate filtration. Wash bottle. Contain distilled water for washing the precipitate. Filtration technique. Gravity filtration. Preparation. Fold the filter paper into a cone and put it in the funnel. Filtration process. Pour the mixture into the funnel slowly down the side. Decantation. Pour the liquid gently to keep the solid from mixing. Vacuum filtration. Vacuum filtration preparation. Put filter paper in the funnel and wet it. Filtration process. Pour the mixture into the funnel. Turn on the vacuum to pull the liquid through, leaving solid behind. Classification based on purity and usage. In analytical chemistry, reagents are classified based on the purity and the specific purpose they are suitable for. The purity level of a reagent determines its appropriateness for various applications, especially in precision analytical work. Classes of reagent. Technical, commercial grade. Reagent grade, primary standard grade, special purpose reagent. Handling and usage guideline. Storage. Keep reagent in a cool, dry place. Labeling. Label container with grade and concentration. Usage. Use only what you need to avoid waste. Safety. Wear protective gear (PPE) when handling reagent. Importance of choosing the right reagent grade. Accuracy. Purity ensure more accurate result. Safety. Impurities in lower grade reagent can be risky. Cost. Use the right grade to avoid overspending.
The final subtopic is cleaning solutions. Why we should clean glassware? The important thing we should clean glassware is to ensure accuracy and precision in volumetry application. Through through cleaning, all glasses must be cleaned thoroughly before use. For burette and pipette, it must allow solution to flow freely and avoid beading on the wall during transfer. For volumetric flask, it ensures the neck is clean for a well-formed meniscus. Now I will teach how to clean glassware with a correct method. First of all, use warm detergent cleaning. Start with warming soap water to remove dirty and grease. If it's not enough, try a stronger cleaning solution. Second is dilute nitric acid cleaning. For tougher stain inside flask or bottle, use dilute nitric acid. Don't forget to rinse it several times with distilled water afterward. The third one is dichromate sulfuric acid cleaning. This is for really stubborn stain. Wear a eye protection and glove while using this method. Dissolve sodium dichromate in water, add sulfuric acid and clean. Stop using the solution when it turns green. For number 4 is aqua regia cleaning. This is the strongest cleaning method. Mix 3 parts hydrochloric acid with 1 part nitric acid. It's very dangerous, so only use it in fume hood while wearing protective gear. For the last one is ultrasonic cleaning. For a high-tech approach, soak a glassware in warm detergent and use ultrasonic vibration to remove dirty in just 5 to 10 minutes.